Welcome to Arxflix. Today, we are discussing an impactful paper titled Progressive Distillation for Fast Sampling of Diffusion Models. This work presents potent solutions to significantly speed up the sampling time of diffusion models, a critical challenge in generative modeling. Diffusion models have shown superiority in generative tasks, often outperforming GANs in perceptual quality. However, their downside is the slow sampling time, requiring hundreds to thousands of steps. The key objectives of this research are: the concept of progressive distillation is at the core. The idea is to distill an n-step sampler into a more efficient n2-step model, continually having the steps while retaining quality. This image illustrates the progressive distillation process. You can see how a 4-step deterministic sampler is distilled into a 1-step sampler. Diffusion models, specified in continuous time, leverage a noise schedule consisting of functions alpha t and sigma t. The forward process Q, mathfx, is Gaussian. The goal is to denoise the latent variable mathfst back to mathfx. The denoising function hat mathfx theta is trained using weighted MSC loss. The weight function W, lambda t, depends on the log signal to noise ratio lambda t. Sampling from a diffusion model can utilize either discrete time ancestral sampling or deterministic mapping using the probability flow ode. Numerical solutions like Euler or Runge-Kutta methods can solve the ode. The DDAM sampler functions as an integration rule for this ode. Progressive distillation iteratively halves the sampling steps. Starting with a teacher model trained in the standard way, each iteration distills the teacher into a new student model, initialized with the teacher's parameters. The training loss for the student model ensures its DDIM step matches 2 steps of the teacher, effectively reducing the required steps without quality loss. The authors tested progressive distillation on CEFR10, ImageNet, and LSUN datasets. They started with state-of-the-art samplers taking up to 8,190 steps and distilled down to as few as 4 steps, achieving competitive results. Here are random samples from distilled models on ImageNet, with different phases of distillation, maintaining high perceptual quality even with fewer steps. Compared to other fast sampling methods like DDIM, the distilled models showed superior performance with fewer steps. Progressive distillation represents a leap forward for practical applications of diffusion models by drastically reducing sampling steps while maintaining high quality. This approach could significantly impact fields that demand generative models by ensuring efficient sampling without compromising output quality. That's it for today. If you enjoyed this detailed overview and want to stay updated on cutting-edge research, don't forget to like, subscribe, and hit the bell icon on Arxflix. See you in the next video. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.